everybody. The sixth expert talk is now closing the circle. It means we are talking about backcasting. First one was about forecasting. And so we have now the situation that we discussed again. How can we predict the uncertainties of air traffic in the future, and how can we do this? Therefore, I would like to welcome two colleagues who worked on this study. First of all, it's Mr. Thomas Standfuß from Institute of Logistics and Aviation, Chair of the Air Transport Technology and Logistics at the Technical University of Dresden. Thanks, Thomas, for joining us. And second one is from Spain, from sunny Spain, Ibon Galarraga from Basque Center of Climate Change and from the Metroeconomica. Both have worked in common together on the study in the InterFAB context, and they will present today the results. So very warm welcome, and I would like to hand over to Thomas.
Thank you, Roland, for the nice introduction. Dear participants, welcome to our presentation, which represent a part of a larger study. And in the last expert talks, we already heard two of the words in the headline, namely forecast and delay. And we would like to link both topics by executing a backcasting exercise. Our aim is to show you that even marginal improvements in the forecasting will lead to significant cost savings. And therefore, there is a structure like that. So I will, in the first part, speak about the motivation, the definition of backcasting. We'll then give an overview about the data, the scope, and the method. And I will take over the first part of the application, namely the backcasting of the delay. Then I will hand over to my colleague Ibon Galarraga, who will present the second part of the application, will provide you with results regarding delay and costs, and give you some concluding remarks. But let's have a look where we start. So the starting point was in the spring when Professor Fricke told us about forecast quality, and he showed us that it is not sufficient for most of the ANSPs. There were two main metrics. The first one was the so-called confidence interval, which means Stadtfor predicts most optimistic and the most pessimistic expectation of traffic, and the span between is defined as a confidence interval. And the aim of Stadtfor is that 50% of the observations are actually in. However, Professor Fricke found out that the confidence interval is seldomly matched, and it was confirmed by the results, which is shown in the graph on the right side. You see the MAPE score, and you can say a MAPE score larger than 10% is insufficient. So if you see the Turkish ANSP, for instance, and the Norwegian ANSP are faced with a good forecast quality. In the opposite, ENAF from Italy, Germany, and also Austrocontrol faced with non-sufficient forecasts. So, but today we don't want to speak that much about forecast quality, but about the consequences. And the consequences are differentiating into underestimations. So when the actual traffic is larger than the predicted traffic, and overestimations. We focus today on the underestimations, and that means the actual traffic was higher than the predicted traffic. The topic is backcasting. So what is backcasting? Backcasting is an exercise to predict the past. So it's somehow the opposite of forecasting, and it enables an evaluation of your forecasting model. I will go more in detail within the next slides. So what have we done? Of course, at first we need to collect data. We used forecast and actual flights, which we used the Stadtfor Spring reports and PRU data. We need the delay, obviously. We had the PRU data. We need delay targets and plan scenarios, and we got that from the performance plans of the FABs. And this was the first point of the work. The second point was identifying saturated airspace in Europe. So why saturated airspaces? Well, additional traffic, what an underestimation would represent, is basically affecting saturated airspaces. So if you had additional traffic in non-saturated airspace, it might not even be a problem. The third point was to check in which years an underestimation occurred. And the fourth one was clustering of flights. That was necessary because PAU data is on daily basis. And since we want to calculate the probability of mismatch, the delay targets, we need to cluster the data. Last but not least is the backcasting. So in this backcasting, we reduce the flights to the expected value of demand and recalculate the delay. And as you probably imagine, you need somehow a functional interdependency between flights and delay. And I will show you how we made it. Though the next slide shows you delay data, which is actually the dependent variable in our interdependency. So we use here PAU data. And the database of PAU contains flights and also delay minutes. And the delay minutes are further distinguished into delay causes. One might say that it makes no sense to use delay causes like weather, since ANSPs have no influence on weather. Instead, we use the CRSTMP delay, which is the abbreviation of ATC capacity, ATC rerouting, staffing, equipment, airspace management, and special events. However, you see in the graph on the right side that the share of CRSTMP delay is quite high. However, it's shifting a bit over the years. So now we have the delay, and we need to further look into the saturated airspaces. So we use two criterions. One might discuss if it's the only ones. You can also use other criterions. So the first criterion was all ANSPs with average delay minutes which are equal or bigger than 0.1 minutes per flight. These ANSPs you will find on the left side of the slide. However, if you have a high average delay minutes, you might have extreme values. So if you have 5 days of a strike or something like this, you will have a high average delay minutes, but in the rest of the year, probably you have no problem with capacity. That's why in the second step, we use the box plot, which are shown on the right side, to have a look how the data is scattered. And you see, for instance, for HCAA, which is the Greek ANSP, that they have a quite high average delay minutes, but also the scattering is very, very high. DFS, German DFS, on the other hand, would fulfill both criterions. And we have now a look at how the backcasting is executed. So what we do is we use the 5-year period, which also Professor Fricker used. And we had a look, okay, what was the expected growth and what was the actual situation in 2019. And you see in the spring report, 2015, Stadtfonds predicted 3.4%, which would lead to 2.8 million flights in 2019. However, the actual situation is somehow different. We had 3.1 million flights, so a large difference of about 8%. I also provide the CRSTMP delay minutes and the average delay per flight. In the graph on the right side, you see that with upcoming years, you have more and more difference between the actual flights and the predicted flights, which is quite normal. And you also see that the actual CRSTMP delay minutes rise more and more and more. And this is exactly what we want to define. So we want now know how does the deviation affect the delay? And this we will do by setting the actual equal to the predicted flights. So how did we do that? I show you now two graphs of observations in 2019. So we clustered the data. This is you will find on the x-axis, and you will find on the left side the number of observations, which is quite important because on the right side you have two graphs in one. So you see the average delay minutes, it's the orange curve, and you have the probability of mismatch the delay target. So this is an example for 2019. And you see, for instance, that there are some extreme values. For instance, you have 3 days between 5,000 and 5,500 flights, which produce a lot of probability of mismatching and also of average delay minutes. And this is obviously an extreme value. But what we want to know is the ADM curve, because it's an approximation for your capacity and also for your interdependency between demand and delay. So what we've done now is that we calculate. So like I said before, we set the actual flights equal to the predicted flights, which means in an underestimation of flights, we reduce the flights of each day by this 8%, which were underestimated. So in consequence, we have 365 observations, and you have a class shift since some of the days now are in another class. So basically, we have a shift to the left side in the matter of observations. And if we now multiply the observations with the average delay minutes, we can recalculate the delay and also the subsequent costs, and can compare these costs with the original costs of the ADM delay, average delay minutes. So the problem is, as you see, this curve is not really steady. So like it should be, you see it in the dashed line, the expected exponential relationship, but it have peaks. So if you calculate your delay and costs, there might be some biases. So how can we cope with this problem? Well, we need a steady function, and you can see it on this graph. We flattening the curve to an exponential function. So we have the dependent variable y, this is average delay minutes, and we have the independent variable, that is the flights, that is on the x-axis. So, and now we search the best fitting curve, which represent the blue curve. And we therefore expect the parameters a and b, which are here in this example 0.8 and 1.8, and we see also that the curve is a very good fit. So what means a good fit? You can use quality model quality criterions like the coefficient of determination, which is shown in the R square. And if the orange curve would be exactly like the blue curve, you have 100% or 1. And if you have absolutely no matching, you would have near 0%, and we have 88%, which is a very, very good fit. However, there are still improvements of this curve, and this is why I hand over to Ibon Galarraga, which will show us how we can even improve this method of calculation.
Okay, thank you very much, Thomas, for your very clear presentation. And let me now try to explain to you how we try to improve the method and the calculations. Well, so why did we try to get rid of the clusters? Because basically what we're proposing to improve a little bit more the calculations is, well, to get rid of these clusters will allow us to improve the mathematical functions to relate delays and flights, because we want to know how these two relate, and we want to extend the analysis also. So basically what we did is we used the daily flights and delay minutes directly with no clusters at all. And we did the similar system or technique as what Thomas just explained about the exponential flattening, but that's directly to the non-clustered data. So basically this way, by estimated functions for each different NASP, we can obtain backcasted daily delay in minutes for every single NASP and for every single year. So what are these backcasted daily delays? Another way of saying it is the delays that will have occurred if the forecasts were right. Okay, this is another way of saying basically the same thing. Of course, we can estimate also the backcasting mean time of delay, and basically fine-tune a little bit better the econometrics or the mathematical analysis here to establish this relationship between the functions. So if we move to the next slide, the second step in the analysis, basically what we try to do is also improve a little bit the economic part or the cost part of the analysis, and this is done starting by some data that was offered by the University of Westminster work. This, I think, everyone is here is pretty familiar with these studies. That there have been several revisions up to 2015, I think, and basically here the University of Westminster Study, what it offers, cost of delay, basically average cost per minute. For 10 different ranges. So if the delay is between 1 and 4 minutes, it will be 16.12. If it's between 5 and 14 minutes, it will be 27, etc., etc., etc. So what we did is we used these ranges, and we did estimate a function also to fit these ranges. I will not go into the details of the function. I mean, this is available upon request for anyone because it's written in a paper. So I will move to the next slide, but just show you in the next slide, that we can see that there is a very good fit again of between the original data given by the University of Westminster. This is the orange part, and the estimated function, the blue one. So with this function now, we can really fine tune and say for any single value of delay in minutes within a range, it can be 1, 2, 1.5, 2.3, whatever we have the data, we can give a more precise figure of the cost. So this will allow us to take into account the whole distribution of the delay. So it's not the same to use the average value as it has been done in the past, and you say, well, the average cost is 100 euros or 104 euros. It's not the same to use that or to use a function that really fits with all these ranges that the University of Westminster was giving, and will allow us to improve much better improve a lot the calculations, and especially take into account the whole distribution of the delays. It's not the same to have a lot of delays of very few minutes, or to have a lot of delays of very, very long-term kind of delays. So if we move to the next slide, please. I will show you a little bit the results we have obtained, and basically there are three things here. First, flights. I mean, we can see that the actual flights were higher than the expected flights, basically, for all NASPs, with some exemptions for Croatia control and also control, and the CIC in 2015 and 2016. But in the table here in green, you can also see that the more you move, the further you move in time, the worse it gets. So this is also very, very common in any forecasting exercise. It's easier to forecast something closer to your time than something more further into the future. So for 2015, for instance, you can see that the difference between the backcasted and the actual number of flights ranges between, I would say, 1.2 and 3.5%. But if we move to 2019, these percentages increase significantly. Okay, so this shows something which we already knew, or probably you already knew, that the more you go, the further you go in time, usually the worse the forecasts are. So if we move to the next slides, we can see the results for the connection between flights and delays. And here what we see is also that the backcasted CRSTMP delay minutes are lower, much lower than the actual CRSTMP delay minutes, both in cluster and non-cluster data, because we are comparing also all the approach that Thomas was explaining before with the second part of the analysis that I'm explaining to you with non-cluster data. So as an example, if we take the data, the aggregated data for FABEC in the line there where these colored circles are, we can see that the actual delays were up to 26 million minutes. This is in blue. If you compare it with the backcasted, and again, let me remind you that this will be the delays that have occurred if the forecast was right, will be between 16 to 18 million minutes. Okay, 18 in red, which is for the cluster analysis, and 16.7, almost 17 for non-cluster. Okay, so there's a huge difference between 32–37% increase in delays when the forecasts are not adequate, let's say. So we will move to the third or the next slide, the third group of results, the cost. I mean, how this increase in delays is reflected in cost. We can say also that the cost of delay is much lower for backcasted delays than the actual ones. Okay, so if the forecast was right, the cost of delay will be much lower than the real cost or the actual cost. Okay, and this again is happening in the case of non-cluster and cluster analysis. There is some differences because of these adjustments and fine-tuning that we have been doing with the data. But for example, again, if we go to the case of FABEC, you can see that the actual cost ranges between 1 to 2.7 billion euros, while the backcasted one ranges between 0.5 to 1.9 billion. So it's the backcasted cost. It's between 30 to 50% lower. So it's a very, very significant difference we have here. So I will basically just move to the final slide when we have some concluding remarks. And and basically to argue that poor forecast is very likely to generate significant delays, and this generates a lot of problems, and the actual delays were higher than the backcasted delays, according to the analysis we have done. And in fact, the fact that you have unexpected flights generates, on the one hand, more delays, but at the same time, longer delays or longer duration delays, which basically means that the cost increases and increases, as we have seen, exponentially. So delays generate very, very significant additional cost to the system, as much as 200%. We have seen that it can double the cost across saturated airspaces. So the cost of the actual delay is much higher than the backcasted delays. And then we have, again, we see some difference between cluster and non-cluster. But again, this is due to improvements in the estimation. So we argue that being able to forecast adequately the expected number of flights, the delays, and the cost is very valuable for good management of the aviation system. And in particular, the backcasting exercises are very useful to predict what may have happened if things were planned differently. They are very good also to test the goodness of forecasting techniques. You don't have to wait 5 years to see whether your model fits well or not. I mean, in some other cases, when you are doing forecasting, you really need to wait until the forecasting time arrives to see whether you were right or not. In this case, you're not, because you are predicting the past. And it gives also a good taste of the resilience of the air navigation system, because you can really do some kind of a stress testing and see what would have happened if things were done differently. So we argue that investing in improvements of forecasting capacities is extremely likely to be very cost efficient. We don't have information on how much it costs or how much can be invested in improving forecasting capacities, but we do know that the cost that is avoided by improving forecasting is extremely high, which means that it's very, very likely, extremely likely, that it's going to be a very cost efficient investment. And finally, just to insist in the idea that evaluations and adjustments of forecast on traffic delay, we have included here also emissions, as you all know that EU ETS is also, emissions are also part of the, the cost of the whole system. We think all this should be executed on regular basis and with a big effort to try to improve the method, which is a very, very economically rational way of reducing the cost of the whole ATM system.
Thank you, Ibon. Thank you, Thomas. Maybe to start with one question, which I have as a very stupid communication guy. There's already forecasting. Why you are doing backcasting? What is the difference? Does it make sense to do it? Where's the added value? Because the results of Professor Fricke, which we have presented here in this forum, I think it was in March, were very pregnant and precise. And where's the added value? Could you please explain it, Thomas?
Yes, of course. So why we do it is we want to show the delay and the costs which could be assigned to forecasting errors. And of course, forecasting is always difficult, and it is to show which costs could be saved in case the actual would be like the predicted value. Since we don't know the exact method and parameters and so on which Stadt for use, it is hard to define a concrete plan how to improve the forecasts. But what we can say is if the forecast improve, we have lots of cost savings. And yeah, that's just basically the statement which we can underline.
Mm-hmm. From your perspective, Ibon, where do you see the advantages?
Well, the advantages I see with the forecasting exercise are, as I was trying to say, is that you don't need to wait. If you are predicting the following 5 years, you don't need to wait 5 years to see whether you are right or not. So you can somehow test how robust your forecasting techniques are. So it's not something to use instead of, it's something to use in, together with forecasting techniques, but doing some backcasting exercises are usually very useful. And again, it's also very useful because it would allow you to analyze alternative scenarios. It's kind of what would have happened if we had planned differently.
Okay, Thank you for this feedback. Maybe 2 or 3 questions to some details of your analysis. There's also 2 from David Marsh from Eurocontrol. I will come back to those afterwards, David. First of all, you mentioned you defined the saturated airspaces. As I'm coming from FABEC, I was quite surprised that Maastricht was not saturated. What is the reason? Can you explain this a little bit? Because I can imagine that my colleagues from Maastricht would question this. And what would be the difference if you would put in their flights or whatever might be the criteria?
Yes, thank you for the question. So first, as I said, there are 2 criterions. Of course, you can use other criterions. However, you need a quantitative measure to say, okay, this airspace is saturated or not. You can also use other criterions. In the results, it wouldn't change that much because it is just a selection of ANSPs which we considered. And if you calculate the delay and the costs for one ANSP more, it is possible. But it doesn't change the overall result, expecting the sum of FABEC or the whole ATM system, maybe. But it would be possible. We use these criterions. We also talk to operational experts, which criterions might be useful. One criterion might also be complexity. One criterion, so you can think about many criterions, and probably the selection of ANSPs would shift slightly. But we decided to take this ANSPs as shown on the slides.
There's a question from David March, as I mentioned already, concerning the data which you use. Was the backcasting casting done with just the baseline scenario, or also do you use also the high scenario?
I think, Thomas, we used both, didn't we? The end and the high end, didn't we?
We asked the ANSPs to provide us the scenario which they are planned on, and this scenario we took. So we had a preliminary analysis of what are the delay targets. They are quite different. So the overall delay target is 0.5 minutes, but since lots of flights are multinational, so you have to split up somehow, and all ANSPs and FABs have own delay targets. And we asked for the delay targets and also for the planned scenario, and this planned scenario we used for the backcasting.
Thank you for the answer. Another point which looks very straightforward to Thomas. Sorry, Ibon, for this, but that's a question from David. It's not a question, it's more a statement, and I would ask you for feedback. In effect, you are using an annual growth forecast to forecast the growth for peak days. Did you look also at the differences? I think peak days trend to grow more slowly than the annual. This might actually make the effect even larger, but needs evaluation. What is your view on this statement?
If I understand it correctly, it is addressing the shift to the left. So I said for each day we use this 8% decrease. So he's completely right. You can discuss if the growth per day might be different. So one day 10%, one day 6%, maybe on some days it's even 0%. That is quite high, but we would need a logic behind. So we didn't find a real logic behind how to deal with it. So we said, okay, there's an even distribution of the reduction. And of course, we can adjust the model if we have another logic how to reduce these flights. We are happy to apply it.
Then another question from my side, Ibon, concerning the results that you presented. I don't remember exactly the number, but you used the example of FABEC to show the difference between actual delay and backcasted delay. And it was, in my understanding, 1/3 of delays would be avoidable. This means there would be less cost if we would go in this direction, if the forecast would have been better. This is an enormous sum. Is this correct, this understanding, or is this the direction? How would you assess the statement?
Basically that's what we are saying here. We are saying that if the forecast were correct, the number of flights will fit with the forecasted number of flights. which means that there will be a limited, let's say, number of delays, or less, much less delays, which means that the duration of the delays will be much lower, which at the end of the day will mean that a huge reduction in the cost of delay. So this is exactly what we're saying, and we have the data for FABEC, but we also have for all the NHSP separately. And this is what we try to estimate. I mean, this is, I know it's an intuition that most of the participants here probably already had or knew, but what we're trying to do here is to put some numbers into these differences.
Okay, so I understood correct. There's a lot of possibilities to improve if we would have a better forecast, and we are not talking about €5 or something like this. We're talking about and how an enormous amount of money.
Yeah.
Maybe one additional point on this. What I have seen is that the forecast that you concluded that the delay cost for FABEC would have been even up to 50% lower if the forecast would have been better. Why is this cost even higher as the minutes of delay? Maybe to make it once again clear, you said 30% for the minutes, but 50% for the delays, for the cost, sorry. What is the reason behind? Where does it come from?
Yeah, well, the reason is that the cost increases exponentially with delays, because two things are happening here. On the one hand, that the more the more flights you have, the more delays you have, of course, and the more delays you have, the more is the duration of the delays, and the cost of longer delays is much higher than for shorter delays. So it's the shape of the curve that we constructed from the data of the University of Westminster, the 10 ranges data that this report is offering. Is the shape of this curve that is telling you that it's exponentially growing, and it's growing much more than minutes. So the cost increases faster and more than minutes.
Maybe before coming to a question from Claire, is my understanding correct that this is related to the aspect of resilience that you mentioned, because then the delays are only minor and you can manage the system in a more stable way as if we would have a lot of delay?
Mm-hmm. Yeah, that's correct.
Okay. So Claire Lelo, I hope I pronounced it correctly. I think you are from Standfuß, as far as I know. Wrote, forecast quality is highly dependent on unpredictable events, strikes, weather. It is difficult by nature to include the latter in our models. What would backcasting improve on this?
I'm not so sure that backcasting is the technique that you need to include or to deal with uncertainty in your modeling. I think you need to include another uncertainty robust methods into your modeling, like stochastic modeling probably, to deal with this uncertainty. And the backcasting will allow you to see whether your improvements in your modeling have been good or not. Whether the improvements in your modeling, if you incorporate, for instance, the stochastic modeling in some of the variables, weather or maybe others also, what you can do with the backcasting exercise, when you have done the different way or you have improved your forecasting capacities, you can do with backcasting is to see whether this in fact has improved or not the results you are getting. This is what you do. So it's not the backcasting itself that will help you to deal with uncertainty, but it will help you to deal or to see whether your improvements to deal with uncertainty are working or not.
If I understood it correct, it's a little bit like a quality check. It's nothing which goes directly into the tool from Standfuß or however they are doing it in the methodology. It's just a quality check and to show if it's getting better or not, and what to do, so you can test what you are doing and what you are changing. Yeah. I hope
absolutely correct. This is some kind of like an ex post assessment of your improvements.
Okay, thanks. I hope this clarifies the point, Claire. If not, just write again. and I would integrate it. Maybe I know that there are also some colleagues from the airlines and from Eurocontrol, from the Commission and from the Westminster University online would be quite interested to hear their voice, what they are thinking and where they do have some points they would like to add in the chat. Another question coming from Matthias. Interdependencies of KPIs is an often discussed issue. Can backcasting help on this? To Ibon and also to Thomas, I think the interdependency issue is something which is always on our table. So everybody has an issue because we are talking about a lot of complexity. However, it's something we have to manage somehow.
Again, as we can compare different situations, I think it could help because it would allow us to compare whether any improvements in the management or in the techniques that we use are working or not. So the straightforward answer will be yes. The proper, let's say, honest answer will be yes, but I'm not sure how yet. But I will think about that, definitely. It's a very good point. I don't know, Thomas, if you want to elaborate on that.
No, I completely agree with you.
Okay. If you talk, if I understood you correct, your idea is that we have to spend some money and some investments to improve the forecasting. That this is really a crucial point for the whole system. If we have a better system and a better forecast, we would save a lot of money. On the other side, this forecast is, I think, where we all agree, it's always a question of the glass bowl at the end of the day, and we will never be absolutely clear about the forecast, how the future will be. What I would like to understand is a little bit your feeling. What will it bring? What's about 10%, 20% improvement, or do you have a feeling on this where it can end up? For sure, not the 50% you mentioned in the cost. This would be an ideal world. That's never the case, but maybe you have a slight feeling in which direction it could go.
Well, I guess to properly answer that question, we'll go back to one of the points that Thomas did before, that we don't really have information on how the forecasting exercise have done. So we'll be more than happy to look at that and see whether we could provide any advice or any ideas on how to improve those. So it's difficult to say or to have a real clear view. What I do know is that the amount of resources you can save by doing any investment in improvement are huge. I mean, the fact that the cost increases so much and exponentially with the delays means that the amount of avoided cost or the amount of savings you can get from small investments in improving forecasting quality are really high. So it's a very cost efficient investment. So 1 to 3, 1 to 2 is it's a very strong or powerful ratio, and the fact that the cost increases so much. So exponentially, I think it opens the door for a huge effort in investments. But again, I don't have the data to be exact on this. But if we had the data, we'll be more than happy to look at it and propose something more specific.
One point which I would like to raise, which is a little bit related to the things which were said by Matthias, that's on the environment. You mentioned at the end the environment, and we know all that this is not only on the side of the European Commission, clearly on state actual the topic. It's also the point that, for instance, in the Council of Ministers in June, it was stated that it should have the environment the same level of priority as safety. So it will come to a calculation, to a monetarization. Do you think at the end of the day that it's possible to incorporate their environment and in such studies? Because
Absolutely.
one thing is to look on cost and delays as we are used now over decades, but times are changing, and I'm not sure if this will be the future.
Yes, absolutely. We can do that. I mean, in fact, there are many ways of doing it. One very straightforward way is to incorporate the CO2, the price of CO2. I mean, the EU ETS, the price of the rights, of the emission rights. And again, it's also a very interesting point because here we will have two different sources of uncertainty. On the one hand, we have a lot of sources of uncertainty related to delays themselves, but then we will have a lot of uncertainty also related to the price of CO2 emissions, that this might change also. It's very difficult to predict what will happen in the market in the following years. So definitely it's a very interesting way forward. There are other also externalities and environmental impacts that can be incorporated into analysis, because there is quite a lot of data and efforts done in order to try to put some value to other environmental impacts. So definitely will be very interesting. And sorry, Thomas, I think you were going to say something else. I apologize for stepping in.
No problem. No problem. Roland, this was a perfect assist because our chair have sent a paper to the InterFAB workshop this year where we exactly address this topic. So how to link forecast with environment KPIs or with horizontal flight efficiency, how to improve, and how can we get the emissions which are produced into the forecasting model. So the paper is already handed in for the workshop, and if anybody is interested, please join the workshop.
For those who don't know, there will be on the 21st and 22nd of September and a research workshop in Vilnius from the InterFAB organized, and there are several papers. I have to admit, I haven't read the paper of your boss, Thomas, so far, so I was not aware. But however, and all those papers will, of course, be published also in this context. Good. One last question from my side. We were talking partially on Westminster. You mentioned that you used the Westminster Study. Of course, it's a study which is very popular and everybody knows, but it's also that they are setting a standard. If we are now go in a direction where we use it, did you were in contact with them on this topic, or how do they see it, or maybe also where are the difference, maybe in the definition of delay? I'm not an absolutely expert. I think they talk about arrival delay and not about departure delay. So please, if you could elaborate both on this and give us some insights.
Yeah, we did get in contact with Professor Cook directly in order to exchange with him. Originally there were some questions because we had some difficulties to understand the study, because the effort they did from the University of Westminster is incredible. I mean, it's a huge and very interesting effort what they have done, and updating all the information. And then we did write the paper, and Professor Cook himself was chairing the session, and we had some comments from him. So we are in contact. I mean, I'm not saying that we have their approval or anything like that to the method that we have used, but they are aware of the work. We will be very looking forward to collaborating with them also and discussing with them any further improvements. We are not experts in delays. We are experts in more in the economic modeling. So I think we could definitely complement a lot the work they are doing, because there is an incredible amount of data there that can be used to define functions and to have mathematical functions that would allow us to fine tune or to adjust a little bit better all the estimations. I mean, one of the things that definitely we don't recommend is to use average values or mean values for the calculation of the cost of delay, because this overestimates or underestimates the calculations very often. And what we have tried to do with the delays is to compare with the previous study. So I think we are on the same page, and And yeah, so I mean, I would be very happy to have any comments from himself or the group or whoever has participated in those studies.
Maybe before handing over to Thomas, I saw that somebody from the Westminster University has registered. Would be quite nice to get a little feedback from him on this work, how it what's his impression of the presentation and the discussion so far. And maybe we can also, as a second action, derive a kind of action on this afterwards. Thomas, your view on Westminster.
I have no additions to the words Ibon said. Of course, the study is very well known and very oft used. And also the calculations of cost based on the clustered data were based on the Westminster study. But apart from that, Ibon said everything.
I do not see any question anymore in the chat. I do not see any question anymore on my preparation paper. So I think most of the things are clear. And I also have to say I was a little bit reluctant on the topic because I never heard about backcasting. That was the first hurdle. The second hurdle, of course, is mathematics, and I'm not a mathematical guy. Therefore, I was also a little bit reluctant. But I think your message was quite clear, Thomas and Ibon, that there's a huge amount of money which we can save if we improve forecasting, and that this method can be used as a kind of quality check and to improve in further, and that it makes a lot of sense to go further in the cooperation to improve the forecasting for air traffic management and the aviation branch. So it would be at the end a very good benefit for all of us. We agreed also with Eurocontrol, with David, that we have a follow-up on this, which is a good point, and I take it on my side also to try to make a contact to Westminster. Maybe this would be something where we can elaborate then in the following times. I would like to say thank you to Thomas in sitting in Dresden and taking the time and preparing all this content. Thank you very much. Well done. I understood what you said, and if I understand it, maybe the others understood or too, or most probably they understood too, because I'm not an expert. The same to Ibon. I heard that you are sitting somehow in 45 degrees in your office, and that it's not too easy in the heat of Spain. Enjoy it anyhow. I hope you all have a nice evening, and have it too. To the audience coming back, I would like to say some final words before I say goodbye. As I said in the beginning, this was the 6th expert talk we did, and a series reflecting on several aspects which are crucial for ATM. And this is really something where I and all my colleagues received a lot of positive feedback. I would really like to say thank you to all who have contributed to the series, coming from all over Europe, from universities, from ANSPs, from research institutes, etc. And this was really something where we put the efforts together in a way which is for me somehow a master example how we should and how we often work together in the aviation branch. And it has also shown for me that there is an urgent need to go in some more details, to go more in some basic aspects of our branch, to understand it better, to make it better, and also to find a way forward. This is today the last expert talk, InterFAB expert talks of the first series. Based on the feedback we received in our InterFAB group, we will continue. So all the colleagues from Baltic FAB, from Danube FAB, from FAB CE, and all the others agreed anonymously that we should continue. But we might change a little bit the format. We might change a little bit the topics, because you need sometimes new consideration, new ways of talking. This will be developed, but it's in the meantime agreed that we will have a follow-up on this. And I'm happy if I would see you maybe in 3-4 months time in a new setup again than in this area. The title of this exercise was Performance, Can We Do Better? And I don't want to copy somebody, but I think we can. That's a clear yes. And that's why we will continue. I would like to say goodbye. Wish you all the best. Enjoy the last summer days and have a good drink tonight and relax. Take care.